Hey guys, so welcome again to the tutorial on basics of mechanical engineering as per the new and revised K2 syllabus. This is module 1. If you haven't watched the part 1 of module 1, click on this link. Now this section covers the important properties of thermodynamics, the laws of thermodynamics, the equations of state, and the most important gas equation which you need all throughout this chapter, and also heat, specific heat, enthalpy, internal energy, all in this brief time of 15 minutes. By the end of this 15 minutes, you will know all you need to know to pass your exam with flying color. So the system is any prescribed and identifiable collection of matter. So this is a system. It can be an object or a quantity of matter. The region surrounding the system is called its surroundings, and that which separates the system from its surroundings is called a boundary. There are three different types of boundary. They are impermeable, isolated, and rigid. Suppose this is a rigid body and some forces are acting on it. If it is a rigid body, there is no change in its size or shape. It retains the shape as it is. That is why it is called a rigid body. An impermeable body does not permit matter to pass through. That is why it is called impermeable body. So we come to an isolating boundary. The difference between impermeable and isolated boundary is that impermeable does not allow matter to pass through, while isolating does not allow matter nor energy to pass through it. Extensive property is dependent on the mass of the system. Extensive property is dependent on the mass, and intensive property is independent of mass of the system. Intensive independent of the mass of the system, extensive dependent on mass of the system. What is path? So consider a thermodynamic system goes from state 1 to state 2, and it goes through three paths, A, B and C. Let at point 1 its pressure be P1, V1 and T1, and at 2 it's P2, V2 and T2. If the property of the system remains the same, no matter which path it flows, that is from A through A or B or C, if the property remains the same and when it reaches 2, it is independent of the path of the system. But if the thermodynamic variable, which is pressure, volume and temperature, depends upon the path followed. That is, if it goes through A one property, through B another property, and through C again another property, it is a path function. Work and heat are path functions. Let's now go through the laws of thermodynamics. The first law is the 0th law of thermodynamics. Let me explain this with an example for easy understanding. So consider two systems A, B and C. This A is in thermal equilibrium with C and B is in also in thermal equilibrium with C. By zeroth law of thermodynamics, if the A is in thermal equilibrium with B, that is, if two systems, that is A and B, are in thermal equilibrium with a third system which is C separately, then they are in equilibrium with each other. So when A is in equilibrium with C and B is in equilibrium with C, then A and B are in equilibrium with each other. Next is the first law of thermodynamics. The first law states that for a system operating in a cycle, the net heat transfer is equal to the net work transfer. That is, integral dQ is equal to integral dW. We just have to put this equation in a statement. That is, the first law states that the net heat transfer is equal to the net work transfer, where Q is the heat and W is the work. But the most important factor is that these systems are operating in a cycle. So, for cases in which systems are operating in a cycle, the net heat transfer is equal to net work transfer. This is the first law of thermodynamics. The second law of thermodynamics consists of two statements, Kelvin-Planck and Clausius statement. Kelvin-Planck states that no actual heat engine working on a cyclic process can convert the whole of the heat supplied to it into mechanical work. That is, this is a reservoir and this block represents the engine efficiency. So, suppose that a heat of Q is transferred to the engine and it does a work of W, and this W cannot be equal to Q according to the Kelvin-Planck statement. That is, the whole of the heat supplied from this reservoir to the engine cannot be converted to useful work. Some of it is lost as heat. That is, W is not equal to Q. Now consider this block. It depicts a low temperature reservoir, that is, a system at low temperature supplying heat to a system at high temperature. This is an impossible statement. That is what is stated by Clausius statement. Now listen to the statement carefully. It is impossible for a self-acting machine. It is impossible for a machine working in a cyclic process to transfer heat from a body at low temperature to high temperature without the aid of an external agency. This external agency can be used to supply the extra push or the work to the low temperature reservoir to the high temperature reservoir. But in the case where there is no external agency, this is not possible. And also, a device which does not obey Kelvin-Planck does not obey Clausius, and vice versa. That is, a device which does not obey Clausius statement does not obey Kelvin-Planck. What are the equations of state? There are mainly three equations of state: Boyle's law, Charles' law and Avogadro's law. But we do not need Avogadro's law for our syllabus. So let's go through Boyle's and Charles' law. Boyle's law states that P is directly proportional to 1 by V, where P is the pressure and V is the volume. Whereas Charles' law states that V is directly proportional to T, where V is the volume and T is the temperature. That is, volume is directly proportional to the temperature. So what is the gas equation? Gas equation incorporates pressure, volume, temperature, and a peculiar constant called as the gas constant, which is represented by R. So the gas equation is given by PV is equal to mRT, where P is the pressure, V is the volume, M is the mass, R is the universal gas constant, and T is the temperature. You have to remember this value, which is R is equal to 287 joule per kilogram Kelvin. Joule per kilogram Kelvin is the unit, and R is equal to 287 for air. Just remember it. It is very useful in problems. Most of the problem takes the value of R as this one, because they have taken air as a factor. So what is heat? Let me explain it in a really simple way. Consider this is a system at higher temperature and the surrounding is at lower temperature. So there is a transfer of energy from high to lower temperature due to the temperature difference. This energy transfer is called heat. So heat is the temperature energy transfer across the boundary of a system due to the temperature difference between the system and the surrounding. This is the system and this is the surrounding. What is specific heat? It is the amount of heat required to increase the temperature by unit degree of a unit mass substance. So specific heat is the amount of heat required to raise the temperature of a substance of unit mass by 1 degree Celsius. There are two types of specific heat. Specific heat is represented by C, and there are two types of specific heat. They are specific heat at constant pressure and specific heat at constant volume. So what is specific heat at constant pressure? If you know what is specific heat, these two are relatively very simple. So whenever a gas is heated at constant pressure, that is specific heat at constant pressure, is called Cp, and specific heat at constant volume is called Cv, in really simple words. The ratio of specific heat, that is Cp by Cv, is given by the letter gamma. So gamma is equal to Cp by Cv. For air, the value of gamma is equal to 1.4. What is internal energy? Internal energy is represented by the letter U. It is a sum of kinetic energy, potential energy possessed by a system. That is, if the system has a number of molecules in it, each molecule have independent kinetic energies, and if they are at a height, they have independent potential energy. So the sum of these energy internally of a system is called internal energy. The change in internal energy, delta U, is directly proportional to delta T. By removing this proportionality sign, we can write delta U is equal to mCv delta T. For ease of remembering that Cv comes with the delta U, just remember like this: U comes V. it's shaped almost similar. So delta U is equal to mCV delta T, not mCp, it's mCV delta T. That is specific heat at constant volume. Also, delta U is equal to delta Q minus delta W, or delta Q is equal to delta U plus delta W. These are just equations you have to memorize. So write down or note it down if you need.